Our T9 topic is Macau Tower. Today we will introduce the project site, environmental and climate conditions, and a brief introduction of the project design. First, let me introduction location. Macau Tower stands on the shore of Nanwan Lake in the southwestern tip of Macau. It is 10th highest freestanding observation tower in the world, and 8th highest in Asia. It is also the highest sightseeing tower in South Asia, surpassing the Eiffel Tower. Macau Tower is close to the seaside, and the south side of the tower is less than 10 meters away from the seawall, but the car can go to the dock and any place in the city. The traffic is very convenient. For the weather, Macau is located in the west of Pearl River estuary, which has a subtropical marine climate due to the influence of monsoon. It is also a typhoon-prone place, which has a great impact on the construction period and finished products. The Macau Tower was designed by the famous architect Gordon Moore of the New Zealand company. The tower height is 338 meters. The construction area is 8,045 square meters. The main sightseeing floor is 223 meters high above the ground. The sightseeing floor in the tower looks out all around and can enjoy the scenery within 50 kilometers. At the top of the tower, a large revolving restaurant commands a panoramic view of Macau. It is one of the famous landmarks of Macau, integrating tourism, exhibition, banquet, and entertainment. This project has the characteristics of short construction period, high quality standard, complex construction technology, and great construction risk. So how to ensure the smooth progress of the project becomes the biggest difficulty at that time.
The following introduces the main problems of Macau Tower construction. The first, Macau Tower is a special hybrid structure with almost no standard floor. In 4 different sections, a variety of structural forms are used, which is difficult and technology intensive. The construction is difficult. Second point, the cross-section of the conical tower is always changing. It is difficult and time-consuming to prepare the formwork, adjust the curvature of the formwork, adjust the clamping formwork system, install and remove the special formwork for each layer. 3. The embedded corrugated pipe and slurry discharge pipe are interspersed in the tense reinforcement, which makes the space congested and the adjustment difficult. It needs to pour different special slurry 5 times, and the technology is complex, so it needs special careful construction. 4. The glass curtain wall, aluminum gasket plate, and upper support are ripped with a prefabricated formwork shell, which is large and heavy, and the installation is difficult and dangerous. And the tower is thin and high, affected by the weather changes. The tower is always swaying. It is difficult to control measurement accuracy. It is difficult to install the communication equipment above 250 meters. There are many specifications, high quality standards, and strict construction accuracy requirements. 8. To the precision of various embedded parts and the thickness of the protective layer of steel bars in the construction of the structure. The concrete compactness, durability, color uniformity, and the circular arc of the template are required. 9. After construction, at a height above 50 meters, is the fire extinguishing ability of cities gradually weakened or even lost. Special temporary firefighting facilities and devices should be equipped, and emergency evacuation procedures and special escape canals should be established. The stair construction. 1. The side and upper surface of the stair step are sealed with overlay wood plywood. As long as the reinforcement is bound and the formwork is installed and the reinforcing is in place, it is convenient for people to pass through and also effectively protect the negative moment reinforcement of stairs. 2. Stair concrete can be poured continuously and formed at one time, which can save labor. 3. In the process of concrete pouring, the closed formwork prevents the overflow of concrete, can save materials and labor, and improve the construction speed. Once forming technology of floor has the advantages of avoiding the common quality problems such as ground hollow drum, thin rise, and cracking, increasing the floor clearance size, improving the wear resistance of the ground, and shortening the construction period. At the same time, it saves the crate layer in the traditional ground construction and has a significant effect on saving building materials and reducing costs. For the concrete pouring of the core tube, due to the restrictions of the building shape and the layout of the internal equipment, the pump pipe and the high throttling method cannot meet the requirements of continuous pouring, and the industry also adopts the weight supporting distributor for pouring. The selection and the layout of the distributor should be combined with the actual construction conditions of the site, taking into account the assembly and disassembly, transportation, stability, workability, and other conditions of the distributor, and adopting scientific and practical methods.
For information management, through a 16-part hub, 10 computers of each department of the project and the computers of the subcontractor, the supervisor, and the office of Part A are set up into a small LAN with star structure and connected to the internet through ISDN so as to monitor the data. These were relative advanced technologies at that time. Next, our group will use more advanced technology and use technologies to achieve the building goal. Thanks for your listening.